Welcome again to my channel. Today we'll be solving another LeetCode question. It is marked hard and it is question number 329, longest increasing path in a matrix. So as you can see, we'll be given a matrix and we have to return the length of the longest strictly increasing path. Strictly increasing path means if you see this example here, the path is from 1 to 6 and 9. It's not 1 1 2 6 9. Why? Because if we go from 1 to 1, it is not strictly increasing. 1 is not smaller than 1, but 1 is also not greater than 1. We want a path where as we move further for each step the number gets bigger. So the answer for this example is 1 2 6 9. Let's see how we are going to approach this question. I've made the same matrix here. So what do we want? We want a path in the matrix which is strictly increasing and we want the longest of that path, right? If you see here, this is also a path 169. It is strictly increasing and its length is 3. However, this path's length is 4 and here that's why our answer in this case will be 4, right? So the first thing to notice here is that the answer can be anywhere, right? uh, you can't say the answer has to be here or from the middle, from the start, from the end. No, there is not a specific cell from which we can start searching. So that means we need to search the entire grid or entire matrix, right? So we'll run a loop that checks that from that current cell does a path start and is it the longest. So what I mean by that is, let's assume we start our search from this one, this cell. Let's say this is our first cell, right? So that means we'll check if there exists a path. If we move this side, there is no path because 1 and 1 it is not increasing. We cannot go diagonally, so the only remaining path is this one, 1 8, and we can't move further because 4 is smaller than 8. So that means in this case, for this cell, the answer is 2. Currently the answer we have got is 2. Now we need to check for other cells if there is a longer path than 2. So we move on to the next cell. Let's say this one. We find this is a path and this is a path. Out of these two paths, we select the longer one, of course, which is 4. So at the moment when we have traversed two cells, we found the answer to be 4. And as such, we'll keep on traversing and we'll check that if a larger answer than a 4 exists in the matrix. That means the first thing that we need to implement is a 2D for loop, right? Then how will we go from one cell to another? Well, that's quite simple. We can only move in 4 directions. Let's say we are in this cell, we can only move up, left, down, or right. So we can do a variable, the normal regular thing, and we can run a for loop for that, right? And I think that will be it. In this approach, however, we'll reach a dead end because we will have a time limit exceeded error. That's because for larger arrays, we are just simply checking every cell, right? We are simply checking every cell. However, if you look at this input, let's say I'm in this cell and I'm searching for this path. I go this way and also this way, right? In doing so, I have already found the answer for this, that is correct, but also I have found the answer for this cell, which is 2, right? And I have also found the answer for this cell, which is 3. So what I'm trying to say is, instead of searching for each cell manually, we can memorize the answers as we go. So we need to implement memorization as well. So let's get to code. It's a simple DFS code. Let's start implementing, and so the first thing we need are the lengths. So m comma n, length of matrix. So this is the number of rows, and matrix of 0. This is the number of columns. So remember, m is the number of rows and n is the number of columns. Next, here we do not need to check if m is 0 or n is 0, because in the constraints it's already mentioned it m and n will never be 0. So I am skipping that check here. Generally we do that check. Then we'll start or we'll initialize a memo 2D array for memoization. Array of int to the length of m, and for I range memo of I equal to make array of int with n. Now this memoization array will initially begin with zeros. We generally use -1 when we are checking for memoization, but here we are using zeros. That's because even if we don't find an array or let's say a longest sequence of um, 2 length, the minimum length of a subsequence will be 1, right? Because the longest, if we do not find the length of 2, the longest will be the cell itself, right? So the minimum answer has to be 1, it cannot be 0. So in this case, that's why we can use the 0 for checking if a value exists or not, right? Then we'll implement the double for loop. Range sorry, not this, 0 I less than m I plus plus, and inside for j 0 j less than n j plus plus. And what will we do? We'll just call DFS for every cell and we'll just take the answer, right? So res equal to max of current res comma DFS of I comma j. The current cell we are on will call DFS for every cell, right? We need to initialize res as well, declare it, and we'll start from 1, because as I said, the minimum answer that we need to send is 1, right? Then we need to implement the DFS function. So var DFS func j, and it will return also an int. Okay, so first thing we check is if we already have the answer in the memo array, right? So if I j not equal to 0, right? Because as I said, we are checking if it is 0, there is no answer available for that cell, but if it is not 0, we can just send the answer. So return memo of ij. If answer is not available, we'll have to do the DFS calls, right? And as I said, what will we do is we will just, for every cell, let's say we are in this cell, we'll try to move in all the 4 directions: up, left, right, and down, right? So for underscore comma d range directions, we'll have to implement that. I think I've copied it. So this is the directions array as usual, and we'll just try to find new row, which will be I plus d of 0. So in the directions array, the first index, 0th index, represents the row, and the second one represents the column. So that's why for the new row we are adding I, because in our case I represents the rows and j represents the columns. So call a row plus the new row value, like if you want to move up, down, left or right. Okay, row handles up and down. So if you want to move up and down, it is controlled by the d of 0, right? Because if it is 1, then we move down, and if it is -1, we move up, right? Then new column j plus d of 1. Then we have to check if these new values are within the matrix limitations, right? If new row should be greater than equal to 0, and new column should be greater than equal to again 0 and new row less than m and new column less than n. And the last check will be matrix of new row new column. Basically the new value should be greater than the current value, because that's where we are trying to find, right? Strictly increasing. So the new value we are moving on to using the DFS function should be greater than the current one. If it is so, then we can move on to like we can move further in the DFS call, right? So max len equal to max of max len comma 1 plus DFS of new row new column. Okay, and again max len will be 1 in this case also, because as I said, if we have called a DFS for a particular cell, the minimum answer of that will be 1, right? Now memo, we have to store that answer that we found equal to max len and we return max len. Again not 1 but res. This should work. Let's try it out. Okay, let's try submitting it. And it is working. Also, I forgot to mention why we are doing 1 plus here and not simple DFS whatever this returns. That is because if we see in the drawing, say I'm here and I'm trying to find the answer for this cell, right? This cell will call a DFS call for this cell and it will calculate this path, right? Not this path, not this path, because this cell is calling the DFS for this cell. Okay, so this DFS call which is being called here will return an answer of 3. So the actual answer will be including this cell itself, the own self, right? Own cell. That's why whatever the DFS call returns, we'll have to add 1 to it, right? That's why we are doing this 1 plus DFS. Okay, and that was it. Hope you understood something, and drop a like if you liked it, comment if you did not understand anything or if you found something difficult, and I'll see you in the next one.